I'm proudly a bike nerd. And with all the mechanical experience that I've got from wonderful races and supporting people like Rich at events, can I build a custom bike for one of the world's biggest bike shows, Bespoked? They've got a show coming up in Dresden. Well, I'm not sure these hands actually can, but I know somebody who is very skilled with, well, all the things that you need to actually make custom frames from titanium or steel or, well, lots of other wonderful materials. So that's why I'm here, is to go and meet Ted James, frame designer extraordinaire. Bespoked is one of the best handmade bike shows on the planet, and builders head there to try and win one of the coveted prizes. These fellow bike nerds build from all manner of materials: titanium, carbon fibre, steel, and even wood and bamboo. So here's the challenge. Can I, Owen the bike nerd, build a bike for this show? Well, time is very tight, so this might be a short video. Let's find out. We're deep in the Cotswolds, trying to hunt down a frame builder extraordinaire. Alas, we've had some sat-nav issues. Should have done the update, and I didn't, so now we're a bit lost. But we're trying to find Ted James. He is a really storied builder, and he can build road bikes, he can build cross-country mountain bikes, he can build gearbox, belt drive, downhill bikes, ones that you've not even dreamt of. And that's because Ted is a really accomplished machinist. The other thing that's fascinating about Ted is that he doesn't muck about with using somebody else's dropout or somebody else's bottom bracket. He makes his own. So he might be the man to be able to help us in this sticky situation. Hi, Ted.
Hey, good to see you.
Yeah, how are you?
Yeah, not bad, thanks.
I need you and your amazing brain and skills to help me build a bike, but for Bespoked. So I need it really quickly.
Well, come to the right place.
Excellent. Let's get started. I'm nerdy and I do like puzzles. And one of the most intriguing and challenging puzzles that there is the 9-tube problem. 9 tubes? Yeah, that's your head tube, top tube, down tube, seat tube, and, well, you've got seat stays and you've got chain stays. 9 different tubes to get into the right place or the wrong place. And it's incredible the number of ways that these tubes have been connected and these dots are all joined up. And it's quite amazing how much innovation there is in this space. So, Ted, I want to build a bike for Bespoked. I say I build, I need a lot of help with it because I'm okay with a file, but that's about it. I think the first thing to talk about is materials, because it feels like there's so many different options. We've got carbon, we've got steel, we've got titanium, we've got aluminium. I guess the other bit of jeopardy that we've got is also Bespoked is actually approaching really quite quickly. So in a way that helps us sort of narrow down some of the options.
Yeah, not a lot of time. Material choices, I think it's fairly easy to make them. Steel's going to be quicker to build than titanium and still give really good ride quality, easier to make the parts in a short space of time. We just got to talk about the geometry, get that dialed.
Okay, on to that, I guess. That's another wonderful kind of wormhole to fall into. Let's go. One of the really amazing things about shows like Bespoked is seeing all the incredibly creative ways of, well, bike builders creating their solution to the 9-tube puzzle. And it feels like it could be limitless. So for this solution, and because the show's coming up really quickly, well, we need to put some limitations in. Right, what's this bike going to be? Well, I'm very lucky and I've ridden lots of really good full suspension bikes from Canyon, from Orbea and from Propane, like the ones we've got here. They're really good. Also, building a full suspension bike as your first bike might be overly challenging, so I think we can park ourselves clearly in the hardtail camp. Hardtails have fallen into, well, 2 different dimensions, or different directions most recently. We've got hardcore cross-country race bikes, like the Orbea Alma. It's an amazing bike. It is head down and hammer. It is really fun for max heart rate and maximum speed. The other direction are the kind of rowdy trail hardtails with long travel forks and, well, loads of tyre clearance and a burly demeanour that can stand up to jumping. And we've seen how I handle berms and big jumps. It's not my style of riding. And the trail hardtail is somewhat elusive at the moment. Another thing I've learned from riding lots of bikes, including this Propane here, is that I really like a mixed wheel size bike. From all the limitless ideas, I think we've now got some limitations. It's going to be a hardtail and it's going to be mixed wheel size. Probably sort of shorter travel trail bike. geometry. It feels like a wonderful wormhole where there's loads of different things to discuss. We've got head angle, we've got not just head angle, all of the numbers together, right? Because that's what makes it the bike ride differently. We've got two examples here of, well, I'll let you go. You talk about them. What have we got?
Obviously, you've got like more old school geometry versus more new school geometry. These are sort of in between. This one's a bit more old school, steeper head angle, slacker seat angle, higher bottom bracket. And this one's a bit slacker, longer, steeper seat angle, lower bottom bracket. 26-inch bikes, if you've got the same bottom bracket height as a bigger wheel, the drop is different. So it's higher in relation to the axle height, so it's less stable. The centre of gravity gets lower with that more drop with the bigger wheels. So it will be more anchored on climbs. It's pretty amazing how the difference. Steeper seat angle, you're more over that when you're climbing. You just, on a 26-inch wheel bike, you need to get right forwards, stop the front wheel lifting up, and then you get wheel spin. But when you've got that lower bottom bracket compared to the axles, it's more anchored. So there's a lot to be said for the newer geometry, but they can get hard to manoeuvre, more boring, harder to pull up when they're so much longer, slacker, makes it less playful. Getting that balance for how you want it to feel is the trick.
I guess I've got to commit to some geometry, haven't I? It's going to be welded in what geometry I want, or are there options to make it adjustable?
So yeah, you can have the adjustable headset with a 44mm head tube. We can get an angle set. You can have an eccentric bottom bracket, like you'd have on the front of a tandem for tensioning the chain. It's a bigger shell with the bottom bracket itself off-centre, so you can swivel that, and that gives us some adjustability in bottom bracket height.
OK, I think that's a must because, well, I'm not sure what I want to go for, but having that adjustment means that I can do it. Right, more food for thought. We talked about a lot of geometry changes before, Ted, and how, well, I was just thinking about geometry in kind of, I guess, like one dimension, but you're already thinking kind of like several dimensions, including time, so like 4D, because you're thinking about how the choices that I make in terms of a head tube angle or a bottom bracket drop are going to impact not only how it rides, but how you're able to make it. And we were talking just about the head tube, and I'm like, well, that's a nice curvy shape. But the choices that I make in terms of an adjustable head angle or an adjustable head tube means that this part needs to be different and how you make it will be different. Can you talk through some of the options that we've got here?
Yeah, so we've got a lot of different head tube choices. As you know, like there's no standard these days. 44mm ID head tube is quite a standard in steel bikes. Aluminium tends to be a bit different, and that is often down to the raw material that you can get hold of. This, we can have an angle set in a 44mm ID head tube. These ones are like integrated. Bearings go directly in. It's one of my own designs, which has a straight wall, nice and easy for joining the tubes too. And I machine the ends individually, press, fit together, weld together, and it means I've got a seamless drawn tube in the middle rather than the grain structure of machining from a solid, which something like this is, which is all curved, which also makes it very difficult for joining your tubes to. You can't just cut with a hole saw and have a fit straight away. You have to hand file. So it's time consuming to get that good fit. We need a good fit to keep good alignment, make it easier for welding.
So we've talked about the different head tubes and how that means that we can actually offer some head angle adjustment. And I guess inadvertently that'll also adjust the bottom bracket a tiny bit because we're having a hardtail, not full suspension. So by moving the fork out, it's going to adjust. But there's other ways to adjust the bottom bracket height and potentially tension the chain or belt, isn't there? What options do we have?
Obviously, for tensioning the chain or belt, you can have sliding dropouts of some sort. So many different types, and I don't like quite a lot of them. It's always best to keep it as simple as possible, whatever you're going for, less to go wrong. Eccentric bottom bracket is a really good way of tensioning a chain. You've got a fixed rear dropout then, so it keeps it good and solid there.
Okay, so that means that we can tension the chain and we can also potentially play with bottom bracket height, I guess, too. So, Ted, what is the geometry of this bike? What's it going to be?
So, geometry, we've gone for 75-degree seat angle, which is It's like on the steeper side, but not nearly as steep as a lot of bikes are going these days. So I think it's quite a good sort of middle ground there. 64.5 head angle we've gone for, but with the ability to go a bit slacker or steeper with the angle set. Chainstay length is the thing that we're not determined just yet. We had it at 440 with a 29 by 2.6, but if we're going for that 27.5, then it's a really good idea to shorten it up a bit. Not being that tall, I think it's good just to go shorter. A lot of people are going longer and longer on stays for that stability, and it can be really good at high speeds and stuff, but then, yeah, it's harder to pull it up, it's less playful. And we've got some limitations with the eccentric bottom bracket. You know, that means we're moving our chainring around further back, and that's the point between the chainring and the tyre is like the most limiting point for our clearance on the chainstay there. So I can only really find that out by actually drawing it. So I'm going to do a 2D plan drawing with those clearances and see how short we can pull that with not squashing the stay too much, or possibly having to put a yoke in there if we need to.
That sounds awesome. Okay, Ted, we've kind of worked out where all the dots are that we need to connect. Now we need to connect them, or I need to connect them, you need to connect them.
Well, yeah, it was obviously a lot of different choice of tubing for different bikes. We've got different grades of tube.
Okay.
And different diameters, wall thickness, and butt profiles. So we've got to make a good choice that's going to reflect in giving the ride quality you want. And then the grade of tube will determine like how thin you can go.
So I guess we've got two things going on in terms of the diameter. We've got the weight, and we've got where the tube shape changes internally, all impacting ride quality in terms of the ride feel of how the frame is going to be dynamically and the overall weight. Okay, over to you in terms of what we pick.
For your bike, I think we go for the bigger down tube with thin wall.
Okay, yep.
And then a skinnier top tube. So we go 31.8 top tube and 38.1 down. So that's inch and a quarter and inch and a half.
Okay.
And this is quite a nice look, I think, having that skinnier top tube. So now I've just sand the end of that.
That feels like a successful first day. I can't wait to see what happens tomorrow. Right, we're at Ted's again. Let's see what progress looks like. Morning, Ted.
Morning.
Oh, wow.
How you doing?
Okay, gee, that looks bike shaped. Really good. How are you?
Good, thanks.
Good.
Yeah.
So, Ted, what is this jig?
Yeah, so this is a fully adjustable frame fixture. It's all set around a 0 point using the bottom bracket as a 0 point of the bike. I normally work on the front end first and then on the rear, but there's no set way you have to do things.
So we've cut the tubes already, and we're using this as a guide to know what angles the tubes are. How are they held in there?
So at the moment, they're not really clamped in place. We've got, we've cut the miters.
Oh. Okay.
So we've got a really nice fit there against the head tube and the cuts for the bottom bracket and scallop for where the seat tube intersects. And that will just sit on there. And you can see like really nice tight fit there. You want them just resting in place for when you tack it.
Oh, cool. Okay, so we've got the stays here. These are the chain stays. And then that's going to be my tyre. Is that the bottom bracket up here?
Yeah, so we've got the bottom bracket here, tyre, dropouts, chainring, and crank arm position and the rotor. It can be really tricky with a lot of bikes. The distance between the chainring and the tyre is is the difficult point.
Okay, that's a lot more complicated than I thought. I can see you've got some bends in here already, but how do you bend a steel tube?
Various different tube benders you can use. I've got one that I looked for years searching for a decent tube bender on eBay or wherever, and yeah, years before I found one that was pretty good. And it's not really an exact science, this. So you go for the first bend. Now we've got some weird shapes going on, which looks pretty good. We'll check with the drawing. Oh yeah, that looks perfect. Be stoked on that.
This looks like it's coming together, Ted. This is exciting. Can I get a bottle cage on there? How do we put a bottle cage on there?
Yeah, we put some bottle. We have to drill a tube and put some bosses in. We'll braze them in.
Right. Okay. Do we just kind of eyeball where it sits, or is there like a maths?
We can eyeball it. We can see it on the computer as well. We can offer it up, but yeah, obviously eyeballing it is good with an actual bottle.
Yeah. I'm going to say about there, but how do we?
Mark 1, and then we've got 64 millimetres between the holes. Have you thought about cable routing?
Ooh, I hadn't really thought about it, but that external looks really nice.
This is pretty good. We've got these little bolt-in guides. So it uses like a bottle cage boss. And they bolt in. This is a single one, but you can get double or triple. It's quite nice and neat and tucked underneath.
Yeah, that'd be great. Do you want me to do it?
I can get you doing it, yeah. If I do it first, then I'll show you.
That'd be fantastic.
Keep moving around in a circle, then the heat's going to be pretty even. I'm just going to introduce this on the edge of the boss, pause with the torch and go around. You see how it is sucked all the way around straight away. I'm just going to go in with a little bit more. And now I'm going to bring this towards the edge of the boss. We need it touching the boss. Pause on it, see it flow in.
Yeah.
And just bring that around, a little bit more, flow around, and then off.
Got to say, I'm a bit scared. Not done stuff with fire for a long time. Right, so that like that.
Yeah, come in and touch closer. That's it. Come off a sec. That's it, and just back in. Come in close. Yeah, good, come off. Okay.
It's not pretty. Have I ruined the tube? That's the big question.
No, that's still, the silver's got in there.
But that's looking clear and flowy.
Yeah.
When it's just sunk
in.
in.
Just sunk down, yeah. Bring that round slowly in circles so it all melts. That's it. That's it. Silver in there. Feed more in, more in, more in. Yeah, that's it.
And then heat off?
Yeah, that's good. Okay.
That's amazing difference.
That's
that
good.
one does look better than that one. Oh, yeah, thanks, yeah. Just another 10,000 hours. I'll get there.
No, you've done really good job on that.
Well, good teacher, thank you.
Yeah, I mean, I've probably brazed loads of bosses much worse than that before.
OK, so is that OK just to stick in the jig now, or does it need a bit of a clean?
Well, we can soak the flux off with hot water, but not before it's cooled down a little bit.
This is going to be our bottom bracket shell. We're using a special eccentric bottom bracket to help with chain tension, and effectively it will play with bottom bracket height and stuff. And it's a press fit, isn't it? So it has to be machined to a pretty high tolerance?
It's high tolerance, similar to press fit. This is not actually an interference fit. It's got to be slightly looser so that it can swivel, but it's still it's got to be within a high tolerance, and we need it good and round and good faces as well.
Okay.
So we need to machine it to right size, slightly undersized first, and then during welding we'll get a little bit of distortion, minimise the distortion with heat sinks, and then after welding we'll ream it out and face the outside.
Okay, and to get those measurements, you know, I've done this with press fit bottom brackets or kind of interface fit ones. A set of calipers is okay, isn't it?
It's not really accurate enough for what we need for this. I've got here a 3-point micrometer.
Ooh.
And for this, the eccentric part is 45.85 of a millimetre in diameter.
Okay.
And we need to ream it to 45.94 for the perfect fit.
Okay, really accurate. I can't even get that on this really detailed caliper. I just can't get that close.
So frame is pretty much there, ready for paint. A lot of work to get to this stage. You're machining components, mitering up the tubes, machining brake mounts, putting in dropper routing, all the brazons, cable guides. Welding is like, you know, fairly quick part of frame building. Clean up, reaming, facing. Paint's quite a process as well. This one I'm going to do epoxy primer directly to it in a colour. We'll put vinyls on and lacquer over the top of that, but it'll still be like 6 coats at least. A lot of work there. Get it ready for paint. So we're using the epoxy primer. It goes directly on as the colour we want, so we don't have a white or grey primer like under the paint that leaves a spot if you chip it. This is a light first coat, and I put 2 more heavier coats on, and then decals, and then the lacquer to give it a deep shine.
We're back at Ted James's. He's finished the frame. I've not seen that, but Ted's also been busy in the paint shop and he's painted it up as well. So, lots to see. Oh, wow. Hi, Ted. That looks amazing. Wow. Not only welded up, but painted as well. That's incredible.
Yeah, I was just about to put the head badge on, last bit.
Awesome. Okay, great. Oh, this is so exciting. Oh, are those, copper rivets?
Copper rivets,
Oh,
yeah.
nice.
The head badge, it's aluminium. I put a vinyl mask and then dip it in hydrochloric acid.
Okay.
Another piece I've made.
Oh, wow.
Axle
Yeah, another piece.
for the UDH with the 1mm pitch thread.
Okay, yeah.
And we have the Rideworks BB turned up today.
Okay, perfect.
And this is all reamed and faced perfectly. We need a really good fit on that.
Okay,
Remember we talked about that before.
Yeah. Okay, awesome. So I need to get shopping, don't I? I need to get parts. Got to get headset. Need to get dropper post. Need to get seat clamp. I need to get brakes. I've got a lot to do. The frame is complete. Is that right, Ted?
Yeah.
Okay.
Ready to go.
Okay, I'll take it. Now I've got to turn this amazing frame into an amazing bike. Can I do that in time for the show? Tune into the next episode and find out.